we've kind of been told this story that you can't change the adult brain, which is just completely untrue. The way that we develop the brain in the first place is by trying things out, and that could be language skills, motor skills, social skills. And it's that effort and failure to learn new things that really drives and crafts the brain. But we stop doing that as adults. So it's not that we can't do it, it's usually just that we don't do it. But there's a whole host of evidence that says if we do continue to really use our brains and develop them and challenge them, actually we can enhance and maintain cognitive function for much, much longer than most people think.
Still having a period, but you're feeling out of whack and you suspect your hormones might be playing tricks on you? It's time to get the lowdown on estrogen dominance with my free ebook. It is the no-nonsense guide to understanding estrogen dominance, how it contributes to pesky weight gain, abnormal, heavy, or painful periods, fibroids, and more. Say goodbye to the guesswork and hello to clarity. Dash on over to ed.hormoneshelp.com, grab your free copy, and get started on your journey to better health. Your body will thank you.
So what if you could have the brain of an elite athlete and have the body you deserve? So today, Tommy Wood and I are going to talk about cognitive health, exercise physiology, and how to live and future-proof your brain and your body. So Dr. Tommy Wood is a neuroscientist, elite-level professional nerd, and performance consultant to world-class athletes in dozens of sports. He's the author of a book that's coming up called Future-Proof Your Brain, Improve Focus and Cognition at Any Age. He received an undergraduate degree in biochemistry from the University of Cambridge, a medical degree from the University of Oxford, and a PhD in physiology and neuroscience from the University of Oslo. Tommy is also an assistant professor of pediatrics and neuroscience at the University of Washington, where his laboratory focuses on brain health across the lifespan, including babies born preterm, adults who experience brain trauma, and the confluence of factors that can affect long-term cognitive function and risk for dementia. Tommy has also published dozens of scientific papers and lectured all over the world about brain health, metabolism, physical activity, and human performance. Alongside his career in medical research, Tommy has also been a performance consultant to athletes and helped found the British Society for Lifestyle Medicine, the fastest growing lifestyle society in the world. And Tommy's experience includes caring for dementia patients, running a team of scientists as part of a neuroscience research program, being a health coach to individuals struggling with a range of health conditions, and working with digital health companies to develop and support individuals in building new habits and improving their health with small actions. He helped Formula One drivers maintain focus and performance while driving at 200 miles per hour. I know I would like that. And these experiences have really given him a broad perspective and an ability to see the big picture and help people, regular everyday people like you and I, with their brain health in a personalized and practical manner. And so I'm going to be so excited to talk Tommy Wood today, and I know you are too. So join Dr. Tommy Wood and I on Menopause Mastery. So Tommy, I am really curious how you got involved in the arena of cognitive performance, exercise performance, fitness. You've had a broad swath of experience over the years. Now, there's got to be a good story here.
There's probably a few. If people really pay attention when they look at my CV, they often raise their eyebrows and are like, how do you do all these random things that seem quite disparate and disconnected, which sort of ranges from running a basic neuroscience lab where we study brain injury in babies through to performance consulting in Formula One drivers and a whole bunch of stuff in between. But in reality, I guess it sort of starts when I was a kid and a teenager, which is I enjoyed sitting a lot, watching TV and eating cookies and not thinking anything related to my health or that wasn't interested in sports or anything like that. I did enjoy science. I was a bit of a nerd at school. I say at school, I mean, I still am. That's how I make a living. But then as I got into my late teenage years and went to university, I got interested in health and fitness. I was a rower as an undergrad and then a rowing coach primarily when I was at medical school. And So through that kind of time, I became increasingly interested in how diet and all these other lifestyle factors affect physical health and performance. But then becoming trained to become a doctor, you then become interested in how that affects our general health. And when I applied to medical school, they always ask you, oh, why do you want to become a doctor? And I was like, oh, I've learned all these things about, how our lifestyle affects our health, and I'd like to help other people with that. Of course, like doctors don't do that, and you find that out later, but that was what I thought going in. And then eventually I didn't know exactly what I wanted to specialize in as a physician. So I did a PhD in neuroscience and physiology, looking at brain injury. That's still what I do with the lab that I run at the University of Washington. But alongside that, I helped found a company that worked with athletes, trying to do everything we could to support their health and performance. And sometimes they came in just trying to keep performing at the level that they were performing at, as they got into their 40s, 50s, 60s, many of them. And some people had some, specific health issues, and we took, what you would call a functional medicine kind of approach. That's something that we did a lot of. Every sample or, fluid that we could get from somebody, we would test it for various things and see if we could help figure out what they can do. And then these strands have eventually come together where now my work encompasses primarily the brain, and I sort of fell into neuroscience during my PhD, but it's kind of brain health across the lifespan. How do we help the developing brain? How do we help the brain as an adult? And then, what can we do to make sure that brain functions as well as possible for as long as possible late into life? And that includes work in humans, in the lab, and everything in between to sort of draw those strands together.
Interesting. I never really thought about that. You would think, you think pediatric and infant and the amount of pathway and just development that happens in the brain. I would think that there's an interesting sort of opposing force of what happens as we're a growing infant and growing through early childhood to what we see in kind of a reversal of that activity and adult cognitive decline, particularly if we don't protect for it. And so I'd love for you to talk a little bit about that, because I'm obviously a nerd, anybody that listens to me. And so I'm always like, there's a part of me that would love to sit in a lab and just go through data and, can we get a sample of that? What did that do? How can I correlate that? But I'd love to hear kind of how those two kind of opposing forces of aging really occur in the brain, which might be a weird question for you, but.
No, it's a really good question, actually, because when I think about this, I think about it a few ways, but one is that when we look at what is required to develop a brain in the first place so that it functions as well as it can, and what does it take to make a brain healthy or keep it healthy in your 70s, 80s, 90s, and like the core components are essentially the same. I think you only see that when you work in each of those fields, and neuroscience in general is very siloed, right? You work just on Parkinson's disease, or you work on just traumatic brain injury. But these are the same brains, and the same sort of principles underlie them. Some stuff does change with aging, of course. So when you're developing your brain in the first place, you're essentially this fully plastic sponge. Like every stimulus, every input is used to craft the brain so that it's kind of adapted to its environment. And that happens very easily and automatically. And that your brain goes through this process of kind of matures, but it also trims back. So you start with more connections and neurons that you need, and then you remove the ones that you don't need through this process called pruning. As you get older, you do then also tend to lose neurons. Although not as much as originally we thought, that as you got older and the brain got smaller, you were kind of like losing neurons, but actually they're just becoming kind of smaller and a bit shriveled up rather than them actually dying. So there's still some potential that you can use them if you choose to. But as you get older, your brain is, at this point, is a function of your environment. And you want it to be, right? You want it to be tuned to the things that you do and the skills that you do. And then because of that, it's harder to change the adult brain. However, we've kind of been told this story that you can't change the adult brain, which is just completely untrue. The way that we develop the brain in the first place is by trying things out. And that could be language skills, motor skills, social skills. And it's that effort and failure to learn new things that really drives and crafts the brain. But we stop doing that as adults. So it's not that we can't do it. It's usually just that we don't do it. But there's a whole host of evidence that says if we do continue to really use our brains and develop them and challenge them, actually we can enhance and maintain cognitive function for much, much longer than most people think. So a big part of it is there's this incorrect story about how the brain functions as we get older. And I think that's really what holds us back. So we need to think more like babies developing their brains in the first place.
That's really fascinating. Yeah, because I think most people think, there's going to be a decline. There's going to be loss of brain volume, loss of neural pathway. So I'm just going to be heading down this road and it's going to happen, right? Like this is an inevitability. And I'm excited to know that it's not necessarily a reduction of pruning, it's shriveling. So that means you can stop the shrivel. So we're going to stop the brain shrivel. So what would be some signs of biological aging that someone could really go, okay, it was particularly around the brain. What are some of the things that a layperson could do with their healthcare provider to kind of assess brain function? What are your favorites? I know there's things that we use, but I'd love to hear yours.
So what's interesting is that when it comes to the brain in this area, it's actually more difficult than you might think for two reasons. One is that there aren't that many ways to test the function of the brain long term, right? We might take blood tests every 6 months, and we might do that. If we're really interested in our health, we may do that for decades. But we don't usually test the brain in a similar way. Part of the reason for that is because there aren't good ways to do that, like easily accessible, well-validated cognitive function tests that you can do regularly. I will say that I'm principal investigator for a charity in the UK called Food for the Brain, which is a dementia prevention charity, and they actually have a well-validated online cognitive function test. So if people do want to do this, which you can do for free. So if people do want to test their cognitive function and track it over time, that is an option. And I would encourage people to do that, because then you actually get some hard numbers that will tell you where you sort of lie compared to people like you. There are other options, and some that I'm actually working on, just so we can even test in the first place. And the reason you mentioned your healthcare provider, they will do standard cognitive function tests like a mini mental state exam or an MMC or a MOCA. But these are mainly to detect problems, like once you actually have cognitive impairment or dementia, which you want to avoid as much as you possibly can, right? You want to know if the trajectory of your cognitive function is changing 20 or 30 years earlier. So there's still a lot of work to be done there. I think there is this idea of subjective cognitive impairment that only we notice before you might pick it up on a formal test. And this is a tricky area that not everybody agrees on, but because often we'll think back to when we were young and we're like, I could remember everything. I didn't need to sleep and my brain just worked just perfectly, and now it doesn't. And some of it is a bit of a recency bias. We assume that we did much better in the past than we did now. So this is why it's a bit controversial. But if you do start to notice issues with, certain aspects of how you perform your work or, your daily activities, and I say it very vaguely because we each want our brain to do different things. So I can't tell you that your brain should do this, because maybe that's not what you want your brain to do. But if you do seem to notice some changes, the main thing is that it's usually not the beginning of some terrible process that you can't stop. Generally, as older adults, people get into their 30s, 40s, 50s, 60s, any changes in cognitive function they may notice are usually related to standard things like they're just not sleeping enough, or, there's a lot of stress going on, you have a lot to juggle, or you have a very high cognitive load, right? And which is higher for all of us as we deal with emails and texts and social media and all this kind of continuous stream of information. So when you have issues, say, remembering somebody's name or where you put down your keys, part of that is a normal change in how our brains work as we get older. It's not pathological. And part of it is because we're probably overwhelmed and underslept. So those things are easily addressable if you take time to address them. The one set of things that you can track with your physician are blood tests. And I think there are some standard blood tests that are easy to get that everybody should probably track. So they include HbA1c for blood sugar regulation. We know that predicts like the trajectory of cognitive decline, the status of certain nutrients, and just the basics will get most of this done. So iron status and like a CBC with differential, vitamin D status, homocysteine is critically important. So like B vitamin status, and then an omega-3 index. So knowing your omega-3 levels, those like basics will get the majority of the work done. And then of course, there are other things we know that like lipids and ApoB containing lipoproteins, we know they're a risk factor for dementia because vascular changes, so changes in your blood vessels, create a part of dementia risk. So measuring those, CRP, so addressing chronic inflammation, those things, all of that's important as well. But just some of those basics can really help you figure out, is there something I need to address, be that with my diet or other aspects of lifestyle, to minimize long-term risk?
Wow. You covered so much. It's interesting because you talked a little bit about, I think when we're younger, we do have this idea that we can remember things. But I would say I had this happen over the weekend. We turned on, I was making dinner. So anytime I cook, I have to have music on. It's just kind of my thing. So I had, my Alexa play, 80s music, because of course I'm a kid from the 80s. And a song comes on and I remember every line of that lyric. And I'm like, if you asked me where I put my keys a half hour ago, I have no earthly idea. And I think a lot of times because we have this incredible retention for this weird stuff, like so-and-so's phone number from when we were 12. Mm-hmm. And then what's happening right here, right now, we can't tell. Everybody thinks, oh my gosh, it's some sort of serious cognitive decline. Is part of that novelty, like this was a novel and heightened emotional state, and that's why some of that sticks longer because it was from those formative years? I'm curious.
Yeah, so some of that certainly plays a role, especially if you learn something in a particular context and you're back in that context, you're much more likely to remember it. And that applies to anything that we do. But part of what you describe is actually a completely normal part of how the brain function changes as we age. And it's not a bad thing. It's just what happens. So as we get older, two things don't really tend to decline. And they are historical memory. So like things that we remember about ourselves from, the good old days. And then other aspects of crystallized intelligence, which is like a fancy term for wisdom, right? As we get older, we become better at synthesizing more information because we have this greater range of experience to then integrate those pieces of information. And crystallized intelligence stays pretty stable as we get older. Everything else, working memory, processing speed, stuff tends to decline with age. Although, like I said, it doesn't have to be that way, right? So we don't assume that it will happen. This is what happens on average in the population. And so that's exactly what you're describing, that you can remember these things from back in the day, but you can't remember where you put your keys down. Now, part of that is because you have put your keys down 40,000 times or something in your life, right? And each individual time is a very insignificant thing that happened in your life. So when you're doing things and you want to remember them, particularly as you get older, remember what I said, when you're younger, your brain is just a sponge. It will take everything in because there's so much space for crafting this organ. But when you're older, if you want to learn things, which you absolutely can, or remember things, you have to tell your brain it's important, right? So you have to focus on it. And then usually there's some aspect of upregulating these processes that we know are important for memory formation. So that's it's one of the reasons why errors are so important for learning. You have to do something wrong and notice that it's wrong. And then that helps you remember it because you release these neurotransmitters like dopamine and norepinephrine that are associated with stress. And actually those help you remember stuff. But that's not what's happening when you're putting your keys down. So it's mainly because by the time you get, you've lived 4 or 5 decades, where you put your keys just isn't important enough to your brain to spend a bunch of time trying to remember it. And that's not a bad thing. It's just part of this. You're collectively working on all these things that your brain will remember and you get better at synthesizing information. But that's at the expense of not remembering every little thing. And actually, that's a good thing, right? You want to forget. Part of the reason why we can have the level of intelligence that we have is because we forget stuff, and purposefully. So hopefully that kind of makes people a little bit more reassured that when they can't remember some of those little day-to-day things, it's not a bad thing. It's part of how the brain function changes as we get older on purpose. But if you really wanted to remember where your keys are, right, you could really focus on it, and you could, find ways to sort of get yourself in this zone that's associated with improved focus and memory and retention. But it's probably not worth your time. So like I said, it all goes back to what you want your brain to be able to do.
Oh, wow. It's funny. I went back to get my PhD at the latter part of my 48th year, 49. And I remember we were in the middle of constructing a building. I'm still seeing patients full time. I run my company and I'm taking full-time classes in the middle of research classes. And I remember I'm a person, I have good auditory learning. I consume data and information very quickly. But I remember during that time period, I would read something and I couldn't retain it. You read the paragraphs, you're like, and they kept coming back to it. And actually, I ended up doing a functional acute EEG and software to see sort of my overall cognitive function, like the Stroop test and trail making and all of that. And we were able to tell, and I'm glad you talked about that software. You can tell in some of those cases, like, is maybe stress, impulsivity, some of these other things that are not a sign of significant cognitive decline really driving the symptoms that someone's seeing.
Yeah.
What do you think about like functional QEEG? I mean, we marry it together with software that does cognitive testing, but what do you think about it?
Yeah, I think this stuff is super interesting and can be very important. And some of it is now starting to become accessible. Like the Misuse headband is pretty good, measuring some of the basic frequencies on EEG. There's some other tech that's coming that, depending on the use case, may be better. And we know that, when you have, so say when you're really focusing on something, you have alpha wave depression. And then as you become fatigued, then you start to see increases in things like theta. So like you can measure this stuff on EEG. The main problem is that it's not particularly accessible and it's not always needed, right? So if we went back and we thought about everything that was happening while you were trying to do your PhD and trying to learn, we probably could have figured out that, stress and some other things were playing a big role here. I mean, I love data and, half of my life is spent essentially as a statistician analyzing data. It's one of my favorite things to do. But, it's kind of a balance between, do we really need this information or is it just like nice to have and cool to have? And so I don't think everybody needs a QEEG because you can probably figure out a bunch of what's going on. But if you want to access it and you have access to those data, it's great. There are some fantastic things that you can discern from it.
Absolutely. Yeah. Personally, I'm myself as a lab rat of one almost every single day. And I would say a whole lot of our patients are like that. But you're right. There's a lot of times just through a really good health history and, some basic lab values, you can kind of see where that sort of risk profile comes from. So from that, we can always figure that out. So shifting gears, we talked obviously about cognitive decline and how to test. And what are some major lifestyle areas that you feel people need to kind of drill in on first when we start looking at, hey, I don't feel like I'm as sharp as I was before? What are your like big go-to areas?
So the way I think about this, I have a sort of a model in my head of what you need to build and maintain cognitive function. And it has three broad areas. The first, and what I think is the most important, is cognitive demand and how we actually use our brains. So the majority of people, their cognitive function increases while they're in standard or formal education. Or I've been asked about this recently, does this have to be in like a standard classroom? No, it doesn't. It's just that period of time up until your 20s or 30s, like your only job is to learn, right? That's all you're doing is giving your brain information, challenging it and increasing your capacities. After that, we tend to go to work and we tend to specialize. So we do the same thing again and again and again. And that is not the same stimulus for the brain. Actually, if you keep doing the same thing again and again, the brain will decrease its function because it will only just retain the functions that you're using. And, we feel like we're challenging our brains. We feel busy and we are busy, but that's not the same thing as really challenging the brain to improve. And the way I think about it is that the brain, and actually you can look at this on the biochemical level, whether you're looking at increases in neuron density or synapse formation or autophagy, all these things, it's very similar to muscles during exercise. So if you want to build bigger, stronger muscles, you have to go to the gym and lift weights or do some kind of physical activity that stresses those muscles. If you sleep well and you eat well and, you're not chronically stressed, you will get more of a benefit from that exercise. But the exercise is still needed, right? It's essentially like you cannot build stronger muscles without it. And the brain is essentially the same. Yes, there are like sleep is critical, nutrient stasis is critical, stress is critical, vascular health is critical. But unless you're actually challenging your brain, those things aren't going to improve your cognitive function. So how we use our brains, I think, is the most important thing in continuing broad skill development related to movement, language, music, all those kinds of things. That's what really drives function in the brain. Then, in order to respond to that challenge, I have this bucket that I call supply. And so supply is two main things. One is a healthy vascular system. So if you increase activity in a certain area of the brain, doing a certain task or learning a certain skill, there's this thing called neurovascular coupling, which is basically the neurons that are active draw more blood supply to that area of the brain to give oxygen and nutrients so that it can do what it's doing. that can't happen if you have significant atherosclerosis or vascular disease. So your healthy vascular system is important. There, exercise, all those kinds of things that work there, very important. People say what's good for the heart is good for the brain. And broadly, that's true. Then having, within supply, we also want some kind of metabolic substrate for most of the brain. For most people, that's usually glucose. So important blood sugar regulation is critical, but it could also be lactate during exercise. It could be ketones if you're in a significant state of ketosis. Just you need to have good regulation of your energy system. And then you need the nutrients to build the cells and the synapses and all that kind of stuff. And that's where omega-3 fatty acids, B vitamins, all, choline, these things become really critical. So kind of to give the structure of those neurons and their connections. Then the last bucket I call support. And so this is if you want to actually respond to the challenge, the way you've challenged your brain and you've built these skills, you need a period of time for that adaptation to occur. That mainly happens during sleep, but it can also be inhibited by a number of things like chronic stresses, and we talked about how that can affect cognitive function, and then a number of things that we might find in our environment that sort of inhibit this process. This could be like chronic inflammatory processes going throughout the body, autoimmune conditions, things like that. Or it could be smoking. Air pollution is a big one. High levels of alcohol can do this as well. So that's how I kind of think about it. You need to challenge the brain. The brain needs to have the stuff that it needs to have at the time so that it can respond to that challenge, and then it needs the period of time in order to adapt. And I put it in those three buckets so that people can say, well, do you know what? I'm always learning a new skill. I'm going to a dance class. I have a language class. I have a good social network. That's great. But, maybe there's more that they could be done in terms of improving their vascular health. Or, they do all of that, but it comes with a side dose of very large amounts of alcohol. So maybe that's where they would focus. So you can kind of pick and think, oh yeah, this is the area that I probably need the most work. And then you can kind of drill down there.
That's great for everybody to hear. So it sounds like also when you're looking at cognitive training, let's call it, just like you would train your body, you want to hit like something that kind of frontal lobe, logical, learning new data sets, skill sets, those kind of things. And then you probably want to explore some of the more artistic side, the other kind of side of the brain. And like, I was always fascinated by the Parkinson's research about, singing and dancing and how effective that was at, affecting like disease progression. So if you were to give somebody some recommendations on that, I would think you kind of go, okay, here's this broad swath of things. You want to kind of hit these, kind of like your different nutrients. You want to hit these different cognitive things. Is that correct?
Yeah, I think so. The brain does specialize, and there are lots of studies that show this. If you become really good at one thing, you become less good at another, because sort of to relate it to exercise again, if you want to be a very fast marathon runner, you're probably not going to be an elite level powerlifter at the same time, right? You specialize, and the brain does the same. So unless you really need your brain to specialize, you want to be hitting everything or as much as possible. So yes, absolutely. You want some tasks that require some, inhibitory control and decision making. So you're using, the dorsolateral prefrontal cortex. But then you also, there's a huge amount of benefit from coordinative movement, play, these other things that have broader benefits. And if you actually look at both cognitive function and mental health, dancing seems to be the exercise that has the most benefit when you look at the effect size of randomized controlled trials, and as well as how it impacts the brain above and beyond just like the physical stimulus. There's probably the musical component, the fun component, the social component. All of these things we know are really critical for the brain as well. I will say that when you look at language learning, skill learning, musical instrument learning or playing, they all have, because they are such broad skills, there's like a visuomotor component, right? You're reading music and playing the instrument, and there's a social component. I think most of these skills that have this very human component to them, like language is another one, right? It requires you to interact with other people and respond to them. I think you don't need to do everything. So you can kind of focus on something that you really enjoy and is beneficial to you, because each of those are actually ticking multiple boxes at the same time. So, because I don't want people to go away and like, I have to take a language class and a dance class, and I need to learn a musical instrument. Oh, and hey, I need to learn, to say code, because that's a new sort of analytical part of the brain. You don't need to do all of that. I would just start with one of those kind of broad skills that we know uses large and numerous parts of the brain, and start there, as, hopefully something that you enjoy as well, because then you're more likely to stick with it.
This brings up a really interesting question. It's a little divergent from talking about somebody in aging, but I think most of my listeners probably have children or grandchildren or something like that. What do you see? Because I know in the States, right, a lot of our school programs have gotten rid of the elementary education around music and the arts and even physical fitness, right? They're like, oh, we don't want to do that anymore. Do you see anything, even in the literature and the research, about removing that at early childhood development?
I think, as far as I know, less has been done on removing those things and the negative impact of them. Though I'm certain they are not good. Like, doing that is not good. Mainly because there are lots of studies that show the benefit of those things, be it physical activity on the brain. There are lots of really nice studies on coordinative movement in kids and how that improves their cognitive function. So like when they're skipping and playing ball sports and things like that, better than like having them just run track, because there's just so many more components of cognitive function they're using at the same time, as well as, arts and music. And there's lots of evidence on the benefit of learning musical instruments for the brain, languages for the brain. So even though I was pretty terrible at all of them, and I'm a growth mindset kind of guy, but like I had dance classes when I was in middle school and art classes, and I hated them and I sucked at them, but I'm still glad I did them because I think they were really beneficial. So I'm concerned that those things are being jettisoned from the curriculum to focus on, more maths or whatever. Like, you can learn that stuff. You can learn that stuff later. I think some of these more artistic and broader, very human components of interaction and cognitive function are really critical during development. Well, throughout the entire life.
Yeah, no, I agree. Yeah, like you, I was definitely not the star athlete, star musician, star whatever, but, I definitely think it added enrichment to my life for sure. And then you also gave me full times. I've been back to school in the 3 separate careers and 3 separate different arenas I've had over my lifetime. Probably helped me. They use different parts of the brain.
Definitely.
So talked a little bit about kind of your bucket and sort of how you look at that. And I have a lot of people that like to quantify how they're doing, what they're doing. What are your thoughts on some of the different devices, biomedical devices, the things people can use, everything from an Aura to a Wear, all that stuff? How do you feel about that?
I'm largely ambivalent towards them, having spent a lot of time working with those kinds of data and clients who collect those kinds of things. And for a few reasons. One, I think it can be very helpful for a brief period of time to use a wearable to really understand ourselves and our behaviors and activities. And that could be continuous glucose monitoring. That could be a Whoop. That could be an Aura to help with sleep, or track sleep, or HRV. And all of this is good data, or they are good data. The problem is that the way these data are used and are interpreted, I think, is largely incorrect and or potentially harmful. So good examples include wearables that measure some kind of level of physical stress or strain and then tell you something about how you should exercise that day. And, I've worked a lot looking at the data on HRV and things like that and physical activity. And your HRV tells you nothing about your ability to perform on a given day, actually. It may tell you something about the physiological cost of a certain physical expenditure, but it doesn't mean that you can't perform well on that day. And so people are using these wearables to say, oh, I shouldn't train today, and they're kind of offloading these decision-making processes from, rather than thinking about themselves and like, how do I feel today? Could I still go and work out? And, maybe I'll just adjust based on how I feel. I think we are losing our ability to understand how we respond to things because we're letting a wearable telling us how we should respond. And I think that is really problematic because you're no longer actually involving your own brain in the process. There's a lot of these wearables, the quality of the data also aren't that good. And there are several studies that show if you tell somebody, say about their sleep, this is one of my favorite ones by Ellen Langer and Steve Lockley at Harvard. If you tell people that they slept poorly or for a short period of time, regardless of how long they actually slept, they will perform worse cognitively because they think they slept poorly and therefore they think they will perform poorly and therefore they do perform poorly, regardless of how they actually sleep. So, when you wake up in the morning and your aura tells you didn't sleep well, you are setting yourself up for a bad day, regardless of how you actually slept. And we know that how we think directly affects our physiology and how we perform. So in the right setting, collecting these data can be useful, but usually if I were to use them as a provider or a coach, I want to see the data, and I don't want my client to see the data, but I can then integrate it and then help them, find intervention points, because there's this obsession with tracking this on a daily basis that I think is negatively impacting our health. And there's very similar things for glucose. So there was another study by Ellen Langer where they looked at glucose regulation in diabetics. They gave them 2 milkshakes. One was like a high sugar milkshake and one was a low sugar milkshake. And as you expect, those who had the high sugar milkshake had a bigger spike in blood sugar that lasted longer. The problem was these were the same milkshake. So the expectation of a blood sugar spike in somebody who's focused on their blood sugar, like diabetics are, creates a stress response that increases blood sugar. So if you're wearing a continuous glucose monitor and you have a piece of cake and you're like, I know my blood sugar is going to spike because I'm eating this cake, you'll get more stressed about it and have an even bigger blood sugar spike than you would have done if you weren't wearing the continuous glucose monitor. So we just have to be really mindful about how we're using these data. Are they good quality? Are we integrating them and interpreting them in a useful way? Or are they just creating stress? And actually, I've seen a lot more in the people that I've worked with. I've seen a lot more stress than benefit from a lot of these wearables.
Yeah. And I would say the more they add on their interpretation, the worse I like it.
Yeah.
Because it's like, oh, your resilience score, I'm like, I feel just fine. And I don't actually, it's more of a curious thing. Like, it did help me fine tune, hey, I've got an airway problem that I ended up fixing with dental work. And that's actually what I would say the greatest utility. So individually varied.
Yeah.
Like, how do you assess that? When they added those other ones, I'm like, though, I always tell, I wait until the end of the day to actually read my data from the night before. Yeah. Because I'm like, I don't care what it really says. I'm just curious.
Yeah, I think that's, again, if you can find a way to use the data that doesn't have the ability to really impact your day-to-day functioning, but can still give you ideas of trends, and, maybe you see a certain thing happen when something else happens during the day, and maybe it's you have the coffee in the afternoon, or you have more alcohol before bed, or you eat really late before bed, and then you can see these sort of trends in your data. I think that's great and helpful. But yeah, the day-to-day reliance on these things to tell us how we should feel and perform, that really worries me.
Yeah, I would agree with you. I'm always like, don't care what they say. Look for trend value. Like CGMs, use them for a month, see what you're doing, and stop.
Yeah, completely agree.
Okay, so you brought up alcohol, and I want to circle back to this because I will say it is the one drug that you have to defend not doing if you're not doing it, right?
Yeah.
And it's the one that people do not want to get rid of. So let's circle back on that because I want you to hit that. So everybody hears it. The wine isn't good for you. Let's talk about what it does to the brain.
It's really funny because whenever you talk about alcohol, regardless of what stance you take, like you said, like somebody's going to disagree with you just because of their own personal feelings. And that includes me, right? I'm not immune to that, of course. So to kind of get the scaremongering out of the way, alcohol is a neurotoxin. We know that. However, that doesn't mean that you shouldn't or you can't drink alcohol. If you look, that one of the problems is that when we look at alcohol research, the people who drink different amounts of alcohol are very different kinds of people. So when you're doing epidemiology, you try and adjust for those differences statistically, but actually that's pretty much impossible. So you kind of have to like squint and infer certain things. In general, a broad range of health outcomes, you may see some benefit with small amounts of alcohol. And I mean small, like 4 fluid ounces of wine a night, right? That's, there may be a small benefit there. And you'll see that across multiple studies when you compare that to no alcohol. Now, the problem is that people who drink no alcohol might drink no alcohol for some other reason. Like it could be a health related reason. So they're already in worse health, or it could be because, they're addicts and they've quit, or, there are other things like there are religious reasons as well. So there's a whole bunch of stuff that's kind of lumped in there. Then people who only drink very small amounts of alcohol every night, they're also a certain type of person. They're usually higher socioeconomic status, higher education, all these other things that we know are protective of their health. They tend to be healthier in general. And then, you get into higher amounts and you can clearly see detrimental effects. So once you get above, once you get above more than one standard drink a day, you start to see some overall negative effects in the literature. At 1 drink a day, on average, there may be some benefit. And you can look at some like mechanistic studies. Alcohol may change blood viscosity. It may do some things in the gut that actually like increase nutrient bioavailability slightly. So there are like some ways that it could be beneficial. The problem is that most people don't drink at that level. They tend to drink more. When you look specifically at the brain, there was a nice study done in the UK using the UK Biobank dataset where they have MRIs on hundreds of thousands of people. And they looked at brain volumes based on alcohol intake. And they saw the same thing again. There was maybe no effect or a non-statistically significant increase in brain volumes in those drinking up to 1 drink a day on average. But then once you got to 1 to 2 or more, those brain volumes started to decrease. So I think it's fair to say that having a beer a night or a very small glass of wine, at worst, no effect. I think we can kind of see that from the literature. But once you get, 2 or 3 times that, there's a strong enough signal from several studies that suggest that's probably not going to be good for your health, particularly in terms of strokes and many types of cancer, because maybe some slightly higher amounts may help with cardiovascular disease, but then that's going to be offset. The overall effect on health and mortality kind of washes out and you start to see a net negative effect.
So if you were to kind of sum up to my listeners, like what's 3 things that they should pay attention to help with their overall cognitive health? Obviously, we're going to talk about your book that's going to be coming up in the future. It's coming out not this next year, but the year after, right?
Yeah, 2026.
Let my listeners know, okay, we've heard about all these pieces. Now I want to really get into my cognitive health. What's 3 things that they can kind of go, okay, I've got a way out of this,
Yeah, so the first thing, I think the most important thing is knowing that your brain is actually this incredibly adaptable, plastic, amazing organ that can still improve its function and late into life. So it always has the capacity to change and improve. And so we already talked about how our thoughts affect our physiology and our health. And this is one of the most important things, is that we believe that our brain is just doomed to stop working as we get older. And that is just not true. So the first thing is just knowing that you have an incredible capacity to change the trajectory of your cognitive function and brain health. Then the second is that the most important way to improve the way your brain works is to learn a new skill. And that it could be anything. We talked about several. Ideally, something that happens in a group or in a social setting, right? That's why music, language, dancing, I think the social component is really critical. And so just pick a skill, try and learn it. It's something that you're bad at now. So actually most of the learning and benefit happens when you suck at it and fail at it and enjoy that process. And, do that, 1 to 3 times a week or something like whatever you have time to do. So that's the most important thing. And then I think because it's something that's not done enough, even in sort of traditional medical care, even though we now have several randomized controlled trials that show the benefit of it, test your omega-3 index and your homocysteine. And the reason for that is that there are multiple trials now that show that if you improve your homocysteine with B vitamins, but you have a low omega-3 index, you won't benefit from the B vitamins. And the opposite is true. If you improve your omega-3 status by supplementing or eating more seafood, whatever, but you have a high homocysteine, you won't benefit from the omega-3s. You need both. And that's because you need both in order to get DHA into the membranes of the cells in your brain where you want them. So those are like 2 tests that I think everybody should do. They're easy to get, and then, supplement or change your diet accordingly.
Fantastic. So, Dr. Tommy, you've got a Better Brain Fitness website that my listeners can go to that can help them, find out some more information. Tell them about that.
Yeah. So a lot of my work, most of my work in this arena is done with a very close colleague and friend of mine, Dr. Josh Turknett, who's a neurologist. And we do have a podcast called the Better Brain Fitness Podcast. It's a question and answer podcast that people can submit questions, and then we answer a question every week. We also have a Substack that has articles we've written as well as links to the podcast and some other things. So that's one of the best places to go. It's betterbrain.fitness. You just type that URL in. And if you sign up, which is free, there's a download that you'll automatically get in your email that has all the nutrients that I talked about today and some others, as well as the foods that you can get them in, and or if you wanted to supplement, and then blood tests that are important to check with your doctor to kind of, if you're thinking about your long-term cognitive function. So you can sign up and get that. And I don't know, it's several pages with like tons of references, if you're into all that kind of stuff.
Also get it there. And so, Dr. Tommy Wood, I am so thankful. Thank you, everybody, for listening to Menopause Mastery, and we'll be back with you next week.
thank you so much for tuning in to the Menopause Mastery Podcast. You are why I'm here, and I am so very grateful. Hit subscribe so you don't miss any wisdom on creating the most exceptional life on our terms. If this episode has helped you in any way, please share it with a friend to spread the love, and together we rise. You can follow me on social media at Betty Murray, PhD, and you can reach me online at bettymurray.com.